Welcome to today's Informed Infrastructure Education Webcast Series presentation brought to you by Bentley Systems. The CEO Series, Greg Bentley on the Evolution of Engineering Software. I'm Todd Danielson, the Editorial Director of Informed Infrastructure. I went to Bentley Systems corporate headquarters in Exton, Pennsylvania to interview its CEO, Greg Bentley. The free-ranging conversation covered many topics, such as digital twins, reality modeling, construction workflows, open source technology, the addition of the time element to engineering models, mixed reality technologies, and the general technology trends in design and construction. We'll get started in a few moments, but first let me cover a few housekeeping items. The materials in this webcast have been reviewed by our editorial staff. However, the views of the speakers and their organizations are their own and do not necessarily reflect those of B1 Media or its media outlet, Informed Infrastructure. If you have not done so already, please turn off your pop-up blocker now. If you have any technical difficulties while viewing this webcast, please submit questions or a brief explanation of your technical problem using the Q&A box toward the bottom of your screen, and a representative will assist you. You also can submit questions to our speakers using the same Q&A box at the bottom of your screen. Submit your questions at any time. We'll try to answer as many as we can later in the webcast. You also can click on the Handouts tab and download the presentation slides and related materials. Informed Infrastructure encourages group learning for our events. If you are viewing the live webcast with a group on one registered person's computer, that person must complete and submit the multiple viewer registration form for the group in order for everyone to earn credit. To download the document, click on the multiple viewer registration form button toward the bottom of your screen. Submission instructions are on the form. At the end of the event, please fill out the webcast evaluation survey for submitting feedback. Your feedback is vital to help us improve our services and deliver more topics that interest you. Toward the end of the event, we will notify when you should click on the Certificate of Completion button at the bottom of your screen to download the certificate. Thank you for joining us. We'll start the interview in just a few moments, but first enjoy a brief message from today's sponsor, Bentley Systems. Hi, this is Todd Danielson, the Editorial Director of Informed Infrastructure. Today I'm with Greg Bentley, the CEO of Bentley Systems. Greg.
Glad to be here, Todd. Cheers.
Thanks for joining us. We're going to ask you a few questions today. We're going to start talking about digital twins. And first I'd like to ask you that digital twins seem to be the next evolution in design and construction. So how would you summarize what a digital twin is, and how does that differ from BIM or reality modeling?
Todd, first I like the word evolution. You know, we say at Bentley Systems, going digital. Some people say digital transformation as if something will be over and done with and so forth. I think we'll always be advancing and going digital, and I think digital twins represents advancements from or of BIM. Also, you mentioned reality modeling. It's a convergence but an advancement of reality modeling as well. And I guess the way I would mark that distinction is we tend to do BIM for a particular purpose. Usually that's somewhat a limited purpose. But when we think of a digital twin, our own twins are live and they're evergreen if we had a twin. So to think of a digital twin for an infrastructure project that becomes an infrastructure asset, it's the same digital twin. It's evergreen over the project and asset life cycle. And if the expectations you would have of a twin need to be met for a digital twin, and of course the first of those is you would expect of your twin reality. So it has to correspond to the physical. We say that's about capturing the digital context of the project or the asset, and we do that through reality modeling. Reality modeling uses overlapping photographs and imagery or laser scanning to the extent that's available, but processes it into a reality mesh that's engineering ready and is the stuff and substance, capturing that digital context, including the environs and surroundings and utilities and so forth for an infrastructure project. So that's the first requirement. You could say it's the reality represented by the digital context. And then we say if it's going to be a twin, the purpose it serves, it needs to explain and provide insights and understanding into the behaviors of what we're delivering or operating in infrastructure. And we could say that that requires veracity, if you like, explanatory capability. To me, the way we accomplish that is for our digital twin to be comprised of digital components that understand themselves. They are the stuff of BIM, if you like, but we can also glean digital components by classifying the reality mesh with machine learning, and maybe we'll talk more about that. So reality, the digital context, veracity, the digital components, and then last of all, you can be digital. It's not a twin if it's not synchronized to the changes that occur over a project and an asset. So I'd like to call that the digital chronology. The change sets to which you would synchronize, you might continuously survey. We say tending to continuously survey on the reality modeling side for the reality, but then the digital components will always change as well over the course of project delivery and asset performance. So reality, digital context, veracity, digital components, fidelity, let's say, maintaining faithfulness to the live evergreen aspect of the infrastructure assets. That's a digital chronology. Put that all together, and on our part, it's taken technology for all of these to converge just at this time, to be able to offer and have the advantages of digital twins for infrastructure assets.
Okay. So what are the main benefits, you would say, for digital twins, and how can they help develop smart or sustainable cities or even projects or just buildings or whatever they're working on?
Well, Todd, let's use this example because when we talk about going digital advancements, there could be the question, oh, well, we're not caught up sufficiently. How will we ever get there? If we talk even about smart cities, if you like, digital cities, cities are made of projects. That's how they're developed and delivered. Projects always start with a site. So I know at Informed Infrastructure, you've covered the release to the market at Bentley Systems of our new Open Site Designer product. And if you don't mind, I'd like to use a site project as an example for the benefits of digital twins. Now, when we say going digital, we have in mind something in particular. Something is digital because and in order that the result of some computerized process can be the inputs to a next digital process in what we could call a digital workflow, where things are connected together in ways that are more productive than approaching them individually. And that's what's behind Open Site Designer for us. So think of the phases from conceptual to preliminary to detailed design. And of course, your project would start with a digital context of a site and a terrain and of zoning restrictions and so forth. There are perhaps brownfield existing aspects to the site, and that tends to be continuously surveyed, if you like. It would start with a reality mesh that's been classified, and that's the stuff to which you then engineer the digital context, if you like, and in the benefits that occur in a digital twin approach, as I could say, describes Open Site Designer. Then during the conceptual stage, you're conceptioneering, if you like, the trade-offs in coverage and drainage and grading and so forth. And you recall Open Site Designer has the veracity, the digital components to cost out and work out the near optimums for the engineer to choose from, permitting a full space of possibilities to be explored, including the geotechnical considerations the technologies we bring together for this at Bentley Systems, and of course the civil and then structural engineering as you consider the particular building when you get to preliminary and then final designs, and always with this reality, veracity, and then the fidelity as the project would move on to construction, which I know we'll next talk about. But the benefits are being able to have the immersive visualization, if you like, where everyone understands the project in the same way. Everyone understands the site in the same way. It'll be an evergreen site. It ends up being enlivened, if you like, with the simulation of the BIM designs and, as you know, the vegetation and so forth that would finish it, so that it can be evaluated as well by the owners and so forth. Thanks to immersive visualization, it's more intuitive and, in fact, easier to use and to adopt than would be the separate technologies, for instance, of BIM or reality modeling. When you bring it together into a digital twin, you can sort of, if for site work that's been up until now done in 2D, you can sort of leapfrog into a digital twin approach with Open Site Designer. So my point is that the advancements are advancements in being easier to use and approach even than preceding technologies, and certainly something that has the same immersion as in our real world is most natural to work with and provide these benefits. Analytics visibility for those who then would like to use their own intellectual property in improving their site design is yet further available in that respect. But you asked about, going to digital cities from, if you like, digital sites, and that's a matter of federating digital twins together. They all have the characteristic that they're geospatially referenceable, and in terms of computer architecture, software engineering, they can be referenced and federated together. In the UK, they talk about a national digital twin. Well, of course, they don't mean one model. They mean following what they call the Gemini principles that describe how this federation can usefully occur, and especially with an open source platform to make that, to have that in mind.
Okay, so there's been other claims in the past with a variety of products that were expected to be the thing that digitized the construction workflow, and it didn't exactly pan out and revolutionize. Why do you think that perhaps digital twins, and maybe it's the Open Site Designer add-in, that's why this one is possibly going to be the one that is going to accomplish that goal?
Well, I know you've described, if you like, that goal as finally fully digitizing everything, and I like to say going digital. There will always be further advancements, but if I would say that digital twins mark a milestone, it's sort of what I've been describing, when the virtual space in which engineers work can correspond to the physical space in which constructors work. They all have the same space and time reference, and the time reference is so important in construction. Then we get to the point where, in construction we tend to be cynical, the world does, but robotics and automated vehicles, autonomous vehicles, not only are possible but are occurring in construction sites that you could say take advantage of digital twins. The project digital twin is so important because if you have only a BIM model and then the constructor creates their own 3D model, it's leaving behind the intelligence which could have been beneficial during, if you like, the live and evergreen stage of the asset once it's operated and maintained. So having the digital twin be live and evergreen from design as an open site designer into construction is what makes it possible to have then the as operated digital twin resulting from the as constructed digital twin that came from the as designed digital twin. And that is kind of conceptually different. That provides a completeness and a potential that wasn't there before. But construction, of course, is about logistics and fabrication and modularization and so forth increasingly. And it's the work packaging that brings that all together that the digital twin makes possible, and then makes possible for everyone involved in the project to similarly understand through the immersive visualization, the continuous and comprehensive status reviews that become possible. And I like to talk a bit about what's then possible, if you like, with the digital twin during construction. So Todd, you may recall at our last year in infrastructure event in London, a major project was presented that's taking place here in the state of Pennsylvania where we are today. It's a huge multi-billion-dollar project on 1,000 acres and where continuous surveying occurs, reality modeling every week so that the BIM models, if you like, of the industrial project can be compared to the construction status and so forth. Well, when you have captured the digital context so completely and comprehensively, it's possible to consider and provide resilience against further risks that could occur on the project. So, by the way, our open flood software can now be utilized to simulate the impact of the expected weather and rainfall, because there's concern about how flooding would jeopardize the construction schedule and construction aspects. You can simulate with our Legion software the pedestrian and vehicle movements on the site, which are so constraining otherwise. And I take note when we talk about construction, as we sit here, there were deaths on a construction site at the Google headquarters in Seattle having to do with wind and cranes. And I see that on Informed Infrastructure, you guys covered wind risks in lifting equipment just last month. And wouldn't you like to be able to simulate the risks and resilience of that? When we talk about smart and sustainable cities, these resilience risks, the flooding, the seismic, wind, putting this all together it's not, if you say, do we finally have it fully done? No, these are just all new potentials that are possible, first of all, in projects that become construction sites for safety there, but then ultimately, as you say, at a city scale.
It seems another technology that's really changing things is open source technology. It's in a lot of products now, and it's bringing a lot of technology together. I know a lot of your newest products use the word open in the names and in the branding. How do you feel that open source technology has changed Bentley's vision and how they're doing things? And why is it now? Is it now just the time?
Well, our vision is for open, for these solutions to be open to the user's choice of tools and repositories and so forth. But if you ask why now, Todd, I suppose it has to do with our background and management ownership here at Bentley Systems. The software developers are in charge here. My board of directors is primarily made of my brothers who are software developers. As you know, one has a chemical engineering background, a mechanical engineering background, electrical engineering background, and they're all at work on our products and have been for these 35 years. But if you're working in software development today, you are daily immersed in and exposed to and taking advantage of open source components and platforms, all the way to the collaboration hubs you use together and that Microsoft is now incorporating in what it has done. Probably you know that IBM made its biggest acquisition ever, and it was an open source software company. It's just software developers have learned that open wins. Ultimately, when there's an ecosystem and a community working together and you have contributors and reviewers and so forth, it turns out to be a fantastically productive environment that I think does lie ahead for infrastructure software engineering. The way we've applied that notion is, on the one hand, we've had some containers for self-description iModels, we called them. Now they go so far as to create digital alignment between the semantic aspects of what different disciplines and phases can be working on in an infrastructure project and enable them to be referenced and synchronized together and their changes synchronized across a hub. We call that an open source platform. It is literally provided in open source so that our user organizations can apply their own skills, their own advancement strategies in immersive visualization. Some of them will call that mixed reality. They have teams to work on that. They have teams to work on analytics and require visibility into the engineering data. It's been dark up until now, obscure formats, but if you can bring it into a hub digitally aligned and then be able to run analytics across projects or a portfolio of projects, and we really, that data exists. The engineers have produced it. The owners have paid for it. To bring it into an open source schema and environment and platform is going, I think, to change a lot about the way we think of things in infrastructure projects and construction. We don't even realize how much we've otherwise made the presumption that all of our data is dark and inaccessible. It's just because it's in specialized engineering formats, but when we can bridge from those formats by way of a cloud service hub to have digital alignment and immersive visualization and continuous and comprehensive status reviews, open's going to win in what we do also, I think, Todd.
Maybe you can help me explain how open source can affect things. Let's say, what would be the differences or the similarities in, let's say, an engineering firm that uses mostly or all Bentley products versus one that's using a variety of products? How might some of the open source be different in those situations?
Well, you use the term an engineering firm, and I think, each of them to some degree are saying we need to improve our business model, to have our own intellectual property, to our means and methods are our stock in trade. How in going digital do we differentiate ourselves? And we say a platform, an open source platform that lets you apply your immersive visualization strategies, your particular devices and ways of working and collaborating, but starting from your actual project universe and the disciplines and tools you use now, and especially analytics visibility, the big data generated, that's your data, and especially aggregating and creating insights and conclusions from that. One example is machine learning. So from continuous surveying of sites, including for design and construction and so forth, you train our software now, the Context Capture Insight software, to recognize and classify the digital components that you find and use on the site. And when it does that, it can tell you about their relative correctness and progress and so forth. But here, you start these days with a platform that allows you just to begin learning and training from your existing projects. I think that's the way it feels to take. Well, let me back up. When software developers develop software, these days they feel that way, that they're standing on the shoulders of open source platforms and are able to modularly improve things without starting from scratch. You don't need to build the foundation. You can simply increase and improve and particularize it for you and your ecosystem. So what about, well, it's our ambition and aspiration to be part of every project with our cloud services that enable this federation to take place. We call this iTwin services, the digital alignment, the immersive visualization, the analytics visibility, that will be ultimately applied by the user organizations themselves. The engineers that up until now have been doing tasks that can be automated in modeling and drawing production and so forth, are in the future going to be working with data to apply their skills and background to analytical solutions and improvements to make our environment and economies more efficient through advancing infrastructure. And the platforms to do that, the cloud services that enable it, are a terrific opportunity for us at Bentley Systems. And our pledge is we want to open up all this dark data, whether it's from our own tools or a mix of tools more commonly. And here again, I think maybe OpenSite Designer is an example of what we work on, things that integrate the disciplines of geotechnical and planning and landscape and drainage and water and grading, and then construction, 3D and 4D. I know we'll talk more about that for the advantages that come from bringing it together.
So it seems another technology that's been talked about for a while that's really finally catching on is time, the 4D element. I know Bentley's got its Synchro software, and that the demonstration I've seen, it works really well. But how easy or difficult is it for people to take past project or past work and try and get that time element put in? Is it too late for that, or can it be added in after the fact?
Well, time is always there. It's really fundamental. It's the fourth D is of the essence in infrastructure project delivery. So to have a timeline across the project, and by the way, with a digital twin, it can be a predictive timeline. I guess I described one example, what if it rains and so forth, from a resilience standpoint. We want to make that very intrinsic. We think every digital twin should have its digital chronology because the changes are of the essence in understanding it. Now, you ask a very interesting question. Your projects completed, can we talk about 4D from those projects? And Todd, that was exactly the point raised when I talked to a major engineering firm, global firm CEO, and his head of digital innovation. He said, in ProjectWise, we have all the projects we've done. Can we learn from those and learn across those what worked and didn't and how we can get better? So I went back after that last week and discussed with our team here that to the extent we have the project representation at various milestone stages, we think we should be able to create the timeline of changes, if you like, the digital chronology for projects of the past, and then apply analytics to what those changes are. In other words, we can go back, we think, but ask me in a few months. I know you will. I'll see you in the fall at Year in Infrastructure in Singapore. But this notion of learning from what we've done, opening up that dark data, and to have that dark data, because project-wise, of course, is used for collaboration across the project and across generally many firms' full project portfolios. We do think there's potential in that. But this notion of chronology and time slider, we want to make it intrinsic to how you interact with a digital twin. This notion that it's live and evergreen, that's what makes it a digital twin. But we can learn from the changes, we can analyze the risks as they were introduced and overcome and so forth, is so vital to improving our project delivery performance.
Okay, since you mentioned the Year in Infrastructure, I was at the event in London, and digital twins were starting to be talked about, and the Singapore event is this fall. Will that be one of the main focuses of the Singapore event? Will there be other things, perhaps OpenSite, or is there something we haven't discussed yet that you're thinking about focusing on for that event?
Todd, digital twins will be an overall theme. I think it's what users and users on their projects will be talking about and putting things into that level of ambition and expectation that I've described. I think even a product like OpenSite, a relatively simple product in theory among our portfolio, represents a digital twin strategy, and I think that users will be advancing BIM, advancing reality modeling, putting these things together. That will be what we cover in Singapore, but we'll be in Singapore. So Singapore is a place where going digital is a national strategy. And as you know, they have a effective government that takes a very long view in Singapore. In fact, Singapore was the first nation in Asia to mandate BIM, but now their emphasis is on what they call integrated digital delivery, and they have 4 aspects to that. So they talk about digital design, digital fabrication, digital construction, and digital asset delivery and management. We're going to be in a country with a strategy that fully developed, if you like, for going digital. So yes, digital twins will be much on our agenda there.
Okay, so you mentioned that Singapore is obviously leading. And 2 years ago when I was there, the event was heavily Asia-focused. There was a lot of cutting-edge projects. And even last year in London, a lot of the leading projects, the most leading edge, were still from Asia. Do you think that's still going to be the case at the Singapore event, or are some of the other countries and parts of the world catching up?
Well, Todd, what was noticeable over the last 2 years, so in Singapore, Year in Infrastructure 2017, you might recall that Chinese projects were selected by the juries in every category of infrastructure, virtually every category. I think they won 10 out of 19 from independent juries that had no Chinese participants, I think, on the juries even. Asians won in 2018 in London again, but this time you could see the rise of Southeast Asia, for instance, including Singapore, but Malaysia and India as well. And you might ask, well, is the phenomenon the same? I don't think so, actually. In China, the projects are of such a scale, and of course they can tackle very ambitious things. They really want to advance the fastest and are the earliest adopters of any of our new technologies. Singapore takes a very long view of their infrastructure investments, and I've described how long that view is as they now look at it. But then you've got, for instance, India. India doesn't have either of those benefits. They have the necessity to improve their infrastructure very quickly because of the way they're growing and urbanizing and so forth. So I contrast, when I was last in China, we visited their ministry that looks after their surveying standards, and they were very well prepared to discuss and advance 3D surveying standards. And the frontier of 3D surveying is now commonplace. Reality modeling starts every project in China of scale and importance. In India, it turns out there isn't an Institute of Survey Standards. There's no formal certification, I think I've been told, in surveying in India. But they're leapfrogging ahead to using reality modeling again, using drone capture and so forth, to enable this continuous surveying that will actually put them ahead in their project timelines, where they've otherwise been waiting for traditional surveys because they just can't wait to deliver these projects and their benefits, their economic and environmental benefits. So the phenomenon have been different across Asia, but we'll see this in the year in infrastructure 2019, I think some considerable advancement. In the Western countries, so here in the U.S., we don't have a long-term strategy. What we do have are more and more privately financed projects, if you like, the P3s and concessions and alternative delivery approaches, in which there's an economic advantage to this integration, the digital twin approach with the digital context, the digital components, and the digital chronology coming together, managing risk and so forth. We are advancing in the U.S. in that respect. The U.K., if we refer to a place where a BIM mandate got a start, as I mentioned, they have a national digital twin strategy that's about federation, and I think does represent where we're all headed with digital twins.
So the Singapore event's still a few months away, but I'm sure that you have a plan as far as some of the things you're going to roll out. Is there any chance you can tip us off to any of the things that you might be introducing there? I'm sure we'll inform our audience as it comes, but any sneak peeks?
Todd, you covered Microsoft's new HoloLens, I think, HoloLens 2, and you had, I think, a month ago or so, an interview with Microsoft. This immersive visualization and what's possible in mixed reality approaches with so many scenarios and benefits for everything that infrastructure engineers do. As you know, we're part of the launch with Microsoft of the HoloLens 2. We were in Barcelona showing projects using 3D and 4D through project delivery, including construction especially. And that will be in the market fully by the time we're together in Singapore. So that's one you sort of have a head start on, but it will come together by then. Something that is advancing very quickly is this notion of machine learning from continuous drone surveys. Where you would produce the mesh and engineer to that, now the machine, you can teach our context capture software what you want to recognize and classify in your digital context or your construction scene and so forth. You can recognize and classify the digital components very much better, very much more quickly, and we'll be showing applications of that. That software is in the market now also. It's Context Capture, latest version with Context Capture Insights. You train it to do this machine learning. It's really a different concept for a software developer which has been thinking in terms of introducing logic and functionality. Now we just introduce this platform aspect, and it becomes smarter on the user's projects and in the user's portfolio. So that will be a subject of much discussion, updating that, because it's changing very quickly, very advantageously. The other thing I'll advise you is we'll be introducing the term digital integrator and some digital integrators. Digital Waterworks is one that has introduced itself to the market, and we'll be following that up with some others that are of relevance to help owners and organizations with taking full advantage of digital twins for improving infrastructure project delivery.
So you talked about the Microsoft HoloLens, and that was something we did just cover in one of our recent issues. Microsoft has since upgraded its HoloLens. It's HoloLens 2 now, and that does seem to be something that a future area that, you know, not long ago again was very high tech, but now it's really becoming part of not mainstream workflows yet, but it's getting there. It's being used more and more, and will eventually get there. How do you see that evolving going forward, and how will that bring more people into the design and construction as well as the management process?
Well, it's interesting that I think Microsoft with HoloLens 2 has defined the mainstream differently. Instead of its video gamers, it is industrial applications such as 3D and 4D immersive visualization on construction projects. And that's what we have helped with in demonstrating that vision, so that everyone on the project has the same understanding of the expectations and the timeline, the logistics, the advanced work packaging, the work breakdown, and so forth is all expressed in the same way between the virtual and the physical, if you like, the same space and time references. Managing the construction site is a matter of managing the spaces and the occupancies and the logistics and the work breakdown. We call it advanced work packaging. All comes together. The HoloLens 2 considerably advances that. Now everyone may have their own strategies of what and how they use that, but essentially when there is the same immersive visualization across the project team, there's one version and you resolve the conflicts, you synchronize the veracity, the fidelity of the project more certainly.
Okay, let's continue our discussion about OpenSite Designer, since that was just released on April 2nd, so that is maybe the newest project, or pretty close.
I think it is, yes.
Okay, so in your words, how would you describe how OpenSite Designer fits within the Bentley software universe? In other words, like, how does it tie the other products together?
Well, what a great question, Todd. You know, site projects aren't necessarily the most comprehensive or complex. They're often not mega projects. I know I described a site project in Pennsylvania. That's a mega project. But every site project should start with the digital context, the veracity of the digital components, the explanatory and optimization capability for drainage and parking and grading and so forth. That should be a digital twin at the service of the engineer, so that they're not spending their time enumerating and calculating those. They're helping make recommendations and understanding and improving the outcome, the viability even of a site project. So we have tried to put all of our discipline software together, from the water and drainage management, the open buildings footprint, the subsurface digital twin, if you like. What are the existing underground utilities? How are you tying in and adding to that? The geotechnical risks and borehole logs and so forth, and the reality modeling in which you'll continuously survey to begin and then to complete the project, and the live evergreen aspect of that. OpenSite caters for all of that. An Open Designer, just to describe its virtuosity, replaces dozens, supersedes dozens of separate software products we had for aspects of that, in which integrating would have been imposing. But OpenSite Designer is intrinsically integrated, it's intrinsically visual, and therefore easier to adopt than would have been any of these predecessor projects. And of course, we did on April 16th a terrific webinar that you moderated, and hundreds of site engineers participated, gave it a 97% satisfaction rating, I happen to see. And I know that's still available on the Informed Infrastructure site to help with that education.
Mm-hmm. So if a firm isn't based on Bentley products, why should they use OpenSite Designer, and how would that work with the other products that they have in-house?
Okay, great question. So we really work hard at Bentley Systems for interoperations with other vendors' software, and Site is an example where there's going to be multiple parties involved, and I like to say our product should be facilitating what I'll call an open information project, where each discipline can choose their own tools, but there's a connected data environment to bring that together that accomplishes the digital alignment that's required. I think OpenSite Designer is a good example of that, and being able to handle and manage formats that are not necessarily our own formats, that can be encapsulated in what we call iModels, that are themselves open source capabilities. And I think an open information project told me to this, that you can do that well and lead the way with OpenSite Designer.
Can you help me understand a little bit more about how does it bring in non-native data formats and make them usable by all?
Well, so first of all, starting with the reality mesh, that of course is accomplished through any overlapping imagery, can include laser scanning if that's available, and the mesh is geo-referenced, understands its spatial characteristics, so it provides this immersive environment in which you can bring anything else that's likewise geo-referenced, including the BIM models to the extent they exist for the project. So that's kind of a good example, is bringing into the terrain and digital context of the utilities and the road network and the existing vegetation and so forth, the proposed or potential site improvements, the digital components, if you like, that will be together managed in what we call a connected data environment.
Okay, so this just came out on April 2nd, which is less than a month ago from now. The host of that event hinted at some of the new things that are going to be coming online. Might you be able to describe a couple of things that you expect in this evolution from the first release?
What I do know is that single-family parcels are, and the optimization of that, we're pretty far along on, but we didn't hold up OpenSite Designer to wait for that. We really do think that site designers who have been working in 2D workflows can sort of leapfrog all the way to a digital twin approach, and do that with a simpler advancement curve because of the immersive visualization, the correspondence of their virtual environment, the engineering-ready reality mesh and so forth, to the actual physical environment, than if they went through a traditional 2D to 3D to BIM and then to 4D and so forth. We're trying to help everyone get to the state of the art now.
This concludes my interview with Greg Bentley. This is Todd Danielson again. I'll be hosting the live Q&A with Adam Klatskin, the Vice President of Business Development, iTwin Services for Bentley Systems, Inc. But before we get started with the Q&A, at this point forward, you can download your certificate of completion. Informed Infrastructure will also send out a reminder email with a link to the certificate after the event. Now we'll try to get as many questions as possible, so let's get right to it. Adam, are you ready?
Yes, I am, Todd.
Okay, our first question. Now, I understand that digital twins can include data such as BIM, reality mesh, and IoT data. But what are the practical next steps to begin implementing digital twins on new projects?
So that's a great question. It depends on where your company falls on the digital maturity spectrum. You'll recognize the most value when a digital twin encompasses the 3 C's, right? That's components, context, and chronology. But you don't need all 3 of them to get started. Depending on your needs, there could be various points of entry. At the least, you need to make sure the digital content is geospatially located, right? Every infrastructure project is going to occur somewhere on or under the earth, and that location's critical to the digital twin for many reasons, right? From a visualization standpoint, it's important because we can bring in maps, terrain, weather, etc. From a simulation standpoint, you could consider seismic activity, flooding, just as some examples. Beyond that, many firms get started by incorporating reality models from context capture, particularly if it's a brownfield project and there are existing assets for which engineering models don't exist. When models do exist or are being created for a project, there are many design tools that may be in use. The components from those applications need to be bridged into the digital twin and aligned. And iTwin Services is an easy way to get started automating that. If you want to link 4D schedules into the digital twin, you can leverage Synchro. iTwin Services, right, it provides a seamless experience for connecting and federating together whatever information you might have at your current digital maturity level to make it more accessible for visualization, analytics, more informed decisions. I'd also note that it's important to recognize that you don't need to wait for a new project to create a digital twin. It's just as easy to get started, again, at your current level of digital maturity on existing projects as well.
Okay, thanks, Adam. Here's one, and maybe you could give me an explanation on this. How are dark data from different engineering applications aligned? Maybe you could start by helping me understand what dark data are.
Yeah, so dark data is it's a term actually that Gartner coined, and it's all the information that you have available that you can't effectively leverage for more informed decisions, for analytics, etc., because that data is siloed and only accessible by a specific tool or application that created it. And on engineering projects, there tends to be tons of that data because there's many different tools and databases, etc., involved. So in regards to how is it, how is that dark data from different engineering applications aligned, the alignment, particularly with iTwin Services, that alignment's achieved with software bridges that are included as part of iTwin Services. And those bridges natively understand the various design applications that are in use. They're automated, and they process that design data wherever it might reside. They normalize that data into a consistent and open schema and continuously synchronize it into the digital twin. And that continuous synchronization is key because it ensures the digital twin is always live and current. The synchronization also, it just contains the changes that have occurred, so you're not constantly resynchronizing all of the design data. So it allows the process to be highly optimized and scale, but it also allows the digital twin to build up a timeline of change so that that now aligned and accessible dark data can be interrogated to understand what has changed, who has changed it, why they changed it.
Okay, thanks. I think this next question might be somewhat related. So are digital twins one-directional and just aggregating data, or are they truly bi-directional?
Yeah, so the greatest benefit of a digital twin is the feedback loop it creates, right? They are truly two-directional. It's that loop that enables improvement of project and asset performance. It might start with aggregation within the digital twin, but that then drives analysis and drives insights, and the results of those activities become actions and interventions that feed back to the physical twin, and the cycle continues. There's also the added benefit of learning that can be mined during that cycle, which can then be applied to all future projects or other assets.
Okay, great. The next question has some feedback and then a question. It says, I see how visualization enabled by digital twins can improve collaboration and understanding of assets. Can you now talk about some of the other benefits of digital twins?
Yeah, absolutely. So digital twins provide benefits throughout the entire life cycle of an infrastructure asset. They can be leveraged in a variety of different workflows. The most basic that almost any organization can easily get started with would be for design review purposes, right? There's lots of different types of review workflows. Each have their own unique needs, whether it's a discipline review, client review, coordination review, constructability review, field inspection, all can benefit being driven through a digital twin. Now, I'm not going to debate there are a variety of tools on the market today that are in use. Nobody's not finding their way to do this using technology, but most of those tools suffer from the dark data problem that we talked about, and they have limitations based on what design apps are being used. Driving the review process through the digital twin takes full advantage of the 3 C's that I was talking about earlier, right? You have, again, for that process, you've got fully aligned components, no matter what tools were used, and fully integrated with all disciplines. You've got context via reality models, so you can see the physical, real-world environment while doing the review. You've got chronology, so you can understand easily what changed since the last review, the impact of that change, or even forward-looking chronology to compare where you are versus where you need to be. At any moment in time, you can conduct a review against the twin, trusting that it's always live and up to date through that continuous synchronization. And then there are the benefits throughout the rest of the life cycle, such as simulations against the twin, like construction logistics, pedestrian movement, flooding, rainfall. You can plan maintenance activities, perform inspections, conduct operator training. The list goes on. All of those being benefits and workflows enabled through the digital twin.
Okay, sounds good. Just checking the clock. Looks like we might have time for about 1 or 2 questions. A lot of our readers are often watching these during a lunch break, and we want them to be late. So let's see if we can do 1 or 2 more. Here's when we get a decent amount. Can you give an example of a project that is using or has used digital twin technology?
Absolutely. So Bentley's Year in Infrastructure event is happening next month, and this year many companies have submitted projects that are using digital twins for the awards program that we run. One of the finalists is in the rail and transport category. It's the Bergen Light Rail project in Norway, and it was submitted by Sweco. They faced a lot of challenges on that project, coordinating activities across many different contracts and subcontracts that were involved. And as one example, using their traditional approaches, they had 10 BIM coordinators that were losing more than a half a day a week each just to check 500 data sets in order to ensure that they were consistently using the latest models. So Sweco recognized that the client requirements and scale required new digital approaches, advancing BIM. They looked towards digital twins, and they ran a pilot with iTwin Services. And they were also in parallel evaluating other technology at the same time. And at the end of that iTwin Services pilot, they recognized benefits in reducing errors, reducing labor, increasing project team awareness and understanding of activities, improving communication with all the stakeholders, including their client, the full supply chain. They calculated that iTwin Services would save 300 hours a week and 1.5 million euro a year on a project of this size. just in the aspect of accessibility and reducing hours and checking what changed alone. So since then, they've started rolling out into production, and they're applying it to other projects.
All right, yeah, that's great. And that brings us right to the hour, Adam. So I think we should wrap up there. Now, if we didn't get a chance to answer your questions, no worries. We'll be passing along all of these questions directly to Bentley Systems so they can personally follow up at a later time. Thank you again for attending today's webcast. Before downloading your certificate of completion for PDH credit, we hope you can complete a quick survey to help us improve our webcasts, as well as find additional topics that best serve your needs. This ends today's webcast. Hope you all enjoy the rest of your day. Please come back for future informed infrastructure educational opportunities. Thank you.